Hello, my name is Jason, and we're going to be going over my digital unit plan, calculus integration in sports. From here, I'm going to go over the entirety of the plan, including how I'll be assessing the students, the lessons taught within this unit plan, the unit plan template itself, and any additional resources the students may need. The unit plan itself is learning how to integrate a graph, generating a volume, so that we now go from a 2D plane to a 3D plane, generating a 3D volume. The end result will be students will learn how to create a 3D shape, in this case a sports ball of their choosing, from a curve they've created to resemble the shape of the ball itself. On the right, we have the California Calculus Standards. These are 4 standards we would like to focus on for this digital unit plan. The first one, students will be relating connections between random sums and area, and random sums and volumes. The next 2 standards are jointly targeted when students are rendering their sports balls on 3D software. The final standard is targeted with a group presentation done by students. The first lesson will be an oral lecture covering the key concepts and definitions covered in this section. Online, there is a short slide presentation to go in tandem with the lecture. There is also a follow-along notes sheet with concept questions for students to fill out and then turn in. You can click both images for a full screen view. The next lesson will have special focus on how to type most forms of mathematical equations and symbols into computers. This is to prepare students for the 3D rendering software that will be used later in the unit plan. To assess the students on this lesson, each student will type up and print their own integral problems with a solutions page. These will be brought to class where students will trade problems and type a new solutions page for the problems they have received from other students. The next assignment for students will be to organize their notes and concepts. This will be in the form of a concept map. Next, I'll be showing you an example of a concept map done of a previous section in our calculus book. This is the example concept map for our growth and decay section, previously covered in our calculus class. As you can see, we have a formula cheat sheet over on the top left corner as recommended in our rubric for this. The concept map continues over to the right. Depending on the amount of concepts covered in this section, the larger the concept map may be. You can also add concepts covered in previous sections to relate to older concepts from our calculus book. The concept map is designed to be turned in. Here we have the rubric for how students will be graded. The example concept map from earlier is an example of what would be expected for an A work. Next, I have 3 different forms of assessments so that I may judge each student's grasp on the covered topics. Each of these I will cover in detail. First, I have created an online quiz for students to take. It is designed to be a short quiz that covers both formal definitions and a few integral problems. This quiz will lead directly into the next exam. However, the quiz should be seen as a halfway mark for this section. Next is the exam. The exam is the first of 2 summative assessments used to conclude this section of our book and lectures. However, not of the entire unit plan. This exam will also have students work in groups. Each group will work on correcting errors of varying degrees that were found in both the homeworks and the quizzes. This method will allow both me, the teacher, and each student to assess where they are excelling and where they may have been struggling. The second assessment to conclude this section is a group presentation. This will be done in similar fashion as the slideshow presentation found in the teacher lecture under the lessons tab. This presentation will have students lecture on using the disk method that was taught during this section, in conjunction with trigonometric functions from earlier in the school year. Each group will be graded on their presentation. Here we have the rubric that will be used to grade the students on their presentation. To prepare students for the quiz, exam, and presentation, I have posted several links to recommended videos and channels for review of calculus topics. I suggest the Khan Academy site as well, as it covers several topics outside of math and can be used as a tool for students to refresh on topics covered in each of their classes. The Patrick JMT YouTube channel, however, is a great source of concept reviews strictly related to calculus itself. Finally, we have the main project itself, the 3D rendering of the sports ball. Here we have the rubric for how each group of students will be graded for their project. As you can see, the categories for which the students will be graded on is a 2D graph in which they measure the sports ball of their choice and then place a curve onto a XY plane based upon the shape of the ball. Next, they'll have the solutions for how the volume of the ball will be generated by rotating it about their XY plane. Finally, they'll be using a rendering software called MapleSoft, for which they'll be generating the 3D graph on the rendering software itself. Next one, they will be translating the rendering software itself to a 3D printer, where they'll attempt to make a 3D object from the printer in real life. Finally, they'll make a compare and contrast paper based upon the actual sports ball they used to start the 2D graph and the sports ball generated by the 3D printer. This digital unit plan is meant to be interactive, creative, and diverse. So I have added a link to the Merriam-Webster Visual Dictionary online database so that students may select a type of sports ball for this project. A real ball must be brought to class for both creating the 2D curve and for a final compare and contrast with the printed ball found from the rubric. If a student wishes to bring a ball not found on this database, please confirm with me that it is an acceptable equipment. Students will be prepared for using the rendering software, in this case MapleSoft, with both an online video for students to watch at home and a class field trip to the school library for a demonstrative lecture in the computer lab. Students will experiment with the software during this lecture so they may be knowledgeable enough to create their final image before transferring it to a 3D printer. Students who wish to use a different software must first check with me to see if the software is acceptable. After the rendering software has been used to create a 3D image, students will submit their work so that it can be printed out on a 3D printer. If students have their own 3D printer or have access to one, they must first let me know if they wish to use that printer instead of the classroom's 3D printer. I have provided a link to eMachine Shop, a program to which it translates 3D rendering software into 3D printers. This will be used in our school library and school computer lab so that we may print out our 3D printers in class. If a student wishes to use their 3D printer or from home or from elsewhere, they must get a translation program so they can translate their rendered image to the 3D printer. After the 3D printed sports ball is made, students will submit After the 3D sports ball is made, students will submit a compare and contrast paper based upon the original sports ball and the 3D printed one. Finally, students will then discuss in class how math, specifically calculus, is used in real-world applications. I have posted 2 videos to start off students for this in-class discussion. In conclusion, the digital unit plan can be found in its entirety under the Unit Plan tab found on the home page. Here it can be seen what is expected of this unit plan and how students will be assessed in this section. This unit plan is 2 pages, so please remember to scroll down to see the entirety of the digital unit plan